Thank you very much for staying until the end. You're very heroic. And I will try to be short, hopefully, so that we can go and enjoy the evening in Rome. So just a little addition to the CV you find on the website. I'm also with the Fondazione Santa Lucia, which is the place where most of the research I'm talking about has taken place. That's the place where I've been working until now, I would say, but I'm now with the university. I have a position at the university, so I had to say I'm with the university. The overview, the summary of the talk will be 4 parts, basically. I will talk about BCIs, so for those of you who have no knowledge about brain-computer interfaces, I will try to give a short overview. And then I will start with talking about the application, especially applications that go towards the users, so something that might find a place in the user's life. And I will make 2 case studies, one for communication, so something to improve communication or restore communication in persons with ALS, amyotrophic lateral sclerosis, and another application in which a BCI-based tool is used as a therapy for post-stroke physical therapy, motor recovery post-stroke. And then I will try to give some conclusions. So, starting from the beginning, what is a BCI? As a community, we had a hard time finding a definition which included all kinds of brain-computer interfaces. But there is some basic arguments that on which everyone agrees, which is the definition as an alternative channel. So we have natural channels from our central nervous system. This channel go through the peripheral, mostly through the peripheral nerves and the muscles. So there is basically no interaction we can have with the environment in a natural way unless we use peripheral nerves and muscles. What BCI does is to detect the activity from the brain, directly from the brain, and with an artificial processing, doing it in such a way that you can interact with the environment, so either communicate or control external devices. It is brain-computer interface, so we're not discussing here the other way around. We're not discussing about how you can manipulate the brain through an artificial channel. We are only one way. So this is basically something I already said. So this is an artificial channel. This is the peculiarity of brain-computer interfaces. So how does it work? First, we have to, of course, to detect when the brain is doing something. So well, how do we detect activity from the